in college. So she really was kind of a pioneer in that area. My father also was a solar physicist. So I have a lot of science in my background. My uncle also, now deceased, was a physicist, Meyer Bloom up in UBC, and my another uncle on my father's side was a physicist. So I guess it's sort of in the gene pool there. Yes, but I do remember, I mean, with my mother, she did have some barriers, and I do remember her saying that when she first was taking physics courses, she was told by the director of the lab that women would not be allowed in the physics lab.
Whoa.
And she just did it. She went in and did it anyway. She basically dared him to throw her out. She went to the lab class and he didn't say anything. So
Wow.
That's the kind of person she is. She's still around, and she's a retired math educator. So
what university was that she attended?
McGill University in Montreal.
In Montreal. Ah,
yeah.
Interesting. Now people might think it, but they wouldn't say it. You know, that we don't want women in this environment.
Yeah. No, I mean, and I did encounter some issues when I was at the University of Maryland. It wasn't, I hate to play the gender card, but there were some things sometimes where I kind of thought that things were a little bit, double standard kind of going on. But, that's the way things have been. I think it's steadily improving. So.
Well, it has to, because women are the majority of undergraduates. So if they want quality students, they have to be open to women graduate students.
Sure, yeah, and I think that there are so many successful women scientists now, more and more, showing that there's no reason to think that women are somehow not capable of doing these things. So we still got a ways to go, but
there was that uproar over Barbie. The Barbie doll was programmed to say something like "math class is hard" or something.
Yes, I remember that. I think I actually wrote an op-ed about that back when that came out. Fortunately, they corrected it, I think.
Yeah, but, I think they did. So what did you major in as an undergraduate?
I actually started out majoring in art. And because I was into pottery. Coming out of high school, I was sort of like, I don't know what to do with my life, right? And I was exploring, had a lot of different interests, and that was something that fascinated me. So I did actually, I have a very checkerboard career in terms of my early educational background. I did some studio art for a while. Then I switched to music education. I do have a bachelor's in music ed. I majored in strings, in violin, and developed hand problems, so I kind of had to abandon that for a while. And that was when I started getting interested in the sciences and in physics, and that's when I eventually turned to that for my graduate study. And I got another undergraduate degree in physics, so kind of changed directions at that point.
And what made you think about it other than your family history? I mean, because that's a big jump from studio art to physics.
It is. Well, incidentally, just interestingly, I was doing, this is going to sound like a complete non sequitur, but this is historically how it happened. I had always been sort of exploring, what is reality? I always wanted to know, what is the nature of reality? And at first I thought I would do it through art. And then I actually got involved in the TM movement, Transcendental Meditation. So I was doing that, and I was going to some of their retreats. And at that time, they had some interesting videos of some professors at Maharishi International University, Larry Domash, who was a physicist and president of the university at that time. And he was talking about physics and quantum theory and quarks, and it just grabbed me. And I said, oh, this is so cool. I remember now my interest in science and in fundamental reality, and that just grabbed me. And that's actually how I got into science, was through being exposed to these ideas again through the TM movement.
How interesting. For a while, TM did some studies where if there's a certain percent of the population of a city that's meditating, the crime rate goes down. I wonder if they followed that up, because that's profound if that's true.
Yeah, I don't know of work following that point. Of course, when I was active in the movement, that information was definitely out there, and I did do the TM City program, which was the more advanced thing where they do try to train you in the Yoga Sutras, and you meet with people. We did some of that. So I'm a bit of a lapsed meditator now, but I do meditate occasionally. But I didn't really follow up, and I don't personally know if they have done more recent studies. It's an interesting idea, and I'm sort of agnostic personally on whether that works, but it's an interesting thing to follow up on.
Right.
Yeah.
What was your family religious orientation when you were growing up?
Well, my heritage is Jewish, but we were very agnostic. My father was kind of a rebel, didn't follow in the orthodoxy of his family upbringing, and my parents were basically kind of scientifically minded. Didn't think that spirituality was rational. They were much more into the kind of logic and rationality, and they just sort of, spirituality, I think for them was like, well, it's fine for those who feel that they need that. And I think they viewed it as kind of a crutch, or, I think they kind of looked down on people who were spiritual.
So what was their reaction when you started doing TM?
Oh, they were dubious. Yeah, I was like, oh, well, she's young. She's going to do these crazy things.
Oh. I think 12 out of 45 people that I've interviewed have Jewish background, and I'm wondering if there's something that would explain why people are the Einsteins and the Freuds and the leaders in thought that comes from having a Jewish tradition. Any wild ideas?
It's interesting. I think there's a strong cultural value of education culturally in sort of Jewish family tradition. Other than that, it's hard for me to really point to anything specific, but there is a strong I did get that feeling, in my family and in my extended family of very much valuing study and higher learning and that kind of thing. So
the same is true for Asian families, but I don't have any Asian visionary scientists. So there's something else, I think, besides valuing scholarship. I don't know what it is.
It's interesting. I mean, I again, my comment here is highly speculative because I'm not an expert in the field or anything, but my sense is that in Asian cultures, there's a stronger drive towards a kind of collectivism in thought and in more obedience to authority. So there may be that factor of obedience to authority, and whether it's the state or some other structure that people may feel like I don't want to question. I want to work hard and learn and value achievement, but as far as going off the beaten path, perhaps there's not as much freedom to do that in that culture.
Right, because in their countries of origin, they've been the dominant culture, which isn't true for people who have a Jewish background. They've had to go around the dominant culture.
Right, so they're sort of marginalized anyway. So kind of I have nothing to lose in exploring these obscure ideas.
Interesting.
Yeah.
So I'm asking people what have been your most difficult challenges and how you coped, because I think it's useful for readers and viewers to know how smart people cope.
Well, I guess my challenge in developing the model that I've been working with, that's been challenging. is that, it's originally John Kramer's transactional interpretation that kind of grabbed me back around the time when I was just finishing my Ph.D. In philosophy of science, philosophy of physics. And it grabbed me, and I just felt like it was an epiphany that, yes, this is how we need to make sense of quantum theory. But I had to kind of go it alone because it was not a popular way of approaching the interpretational issues of quantum theory, and still isn't, So I think my hardest challenge is kind of swimming upstream in also developing the model past where its point where it was originally presented, which was only a non-relativistic model. I don't know why I said novel. Anyway, novel idea, but
a novel idea, yeah.
Yes, it was a non-relativistic model. So one of the problems that I saw in interpreting quantum theory was that it was always being limited to the non-relativistic range, which is not the full range of nature. Nature is relativistic, including higher speeds, higher energies, and so on. And relativistic physics is very different from non-relativistic physics. So that was my challenge. I had to kind of do that all on my own because no one else was interested. So there was just a lot of kind of self-teaching, and even though I do have the master's in physics, and I did some graduate work beyond that, I didn't take certain courses, so I had to do a lot of my own, figure out quantum field theory, and so on. So I had to do a lot of self-teaching and there weren't people around that I could say, help me make sense of this model, because no one else, it's been very much rejected for certain metaphysical prejudices and so on. So there was that, just kind of having to go it alone and kind of beat my head against the wall, a lot. So, but it was rewarding in that, despite having to kind of be on my own and figure out these problems, I could get help every now and then, but I was able to kind of see breakthroughs that were encouraging enough that it was, helped me keep going with it.
Well, what about, how many children do you have?
I have 2 daughters.
And being a faculty member and a graduate student and a wife and a mother, that's a lot to juggle. So I'm wondering how you handled that challenge.
Well, actually, I wasn't employed full-time while my daughters were young. So I was at home, and I was able to do that. Fortunately, my husband has been an electronics engineer, and so he was able to carry that the financial burden while I was able to be home for my daughters when they were young. So that was very special. And I mean, the other side of that is because I've been working on an area that's viewed with some dubiousness by the academic community, I've never had a real steady full-time academic position. So I've been mainly self-employed. I've done part-time and been at a variety of different institutions. So I've done a lot of teaching and research at various places, but I have not had a full, I don't have tenure anywhere. So, that's the downside. I'm kind of an independent scholar in many ways.
Mm-hmm. Well, let's talk about this transactional interpretation of quantum mechanics. So, as if we go through it, the basics as you've written about it, an atom produces an offer wave, which is like, I have this particle I don't need anymore. Does anybody want it? And is it a particle? Is it a electron? What exactly does the atom offer in this wave?
When you have this atom, it's in an excited state, meaning that one of its electrons has basically an extra quantity of energy that will take the form of a photon, a quantum of light, if it's emitted. So that's the particle we're talking about, although it's not a little, in my model, it's not a little localized corpuscle, but it's a kind of a discrete amount of energy. And what happens is when you've got this atom that's in this excited state, it's kind of a bit unstable, and it wants to relax down to a lower state. So, and when we talk about offers, at the relativistic level, it's not really a unilateral thing where this one atom is just saying, I've got an offer, how much am I bid for, this photon. There's actually a mutuality to it, so that any particular excited atom will not be able to generate this offer unless there are potential absorbing atoms around. These would be atoms in a lower state, like a ground state, or some other state that in which they could be capable of assimilating the photon and popping up to a higher state. So that you have to satisfy energy and momentum conservation in this process. So in a way, there is this non-locality that I think people find challenging, where the at this level, in this what's called the direct action theory, it's a specific theory of fields that the transactional picture is based on. They are in a kind of direct contact through what are called virtual connections, virtual photons, but those are not offers or confirmations. They're just kind of a sensing, a non-local awareness, if you will, that these atoms have. They kind of know about each other. And so when you do have an excited atom and some other atoms that are lower levels, the atoms are kind of in a communication sort of mutuality, where at some point, and this is indeterministic, but at some point then they can generate an offer and usually many different confirmations from different possible absorbing atoms. So then you get this sort of handshake process. So that's really, yeah, go ahead.
Do you know that by observation or experiments, or is it a mathematical model? How do you know that they have this kind of communication? I'm thinking of it kind of like if there's a dog in heat, the other dogs kind of sense, oh, she's in heat, and they kind of get the scent, and then they try to hook up with the dog. And
that's an interesting analogy. I mean, it's a good analogy for the basic idea here. It is a mathematical model, so this is not something that anyone can detect experimentally. But so what you have here is the particular kind of non-locality and sensing that goes on is a property of this direct action theory of fields. And that was actually invented back in the 1940s by Wheeler and Feynman. And they came up with it for different reasons, for a reason of trying to deal with certain problems in physics having to do with infinite self-energies, where a charge seemingly interacts with its own field, and then you get, the theory seems to predict these enormous energies that we in fact don't see. So that's actually why they were developing the direct action theory, because it was a way of getting around that kind of problem. And it had other advantages in that it accounted for the fact that when you have an accelerating charge, it radiates and loses energy. And in the usual approach to electromagnetic theory, it's hard to explain that. So they actually came up with this model as a way of solving certain theoretical problems in physics. And then later they abandoned it for various reasons, because they felt that they didn't need it anymore, and it sort of fell into disfavor. But it's a perfectly good model, and it does have this advantage of explaining certain things that the standard approach has trouble with. So that's the nature of the model. It is a mathematical model that explains certain theoretical problems better than the standard approach.
So the atom sends out an offer, I've got an extra photon, and then an absorber says, okay, I need it, and they exchange. The particles is transferred, but it happens retroactively. So explain the time lag, because that's interesting.
Sure. So the interesting thing here is there's a lot of confusion about this, possibly because there are different ways to understand what's going on with this so-called retroaction or retrocausality. Now, people usually think when they hear this that, these confirmations are the advanced waves, meaning they go back in time, right? But what my proposal deviates from that kind of picture, in that these offers and confirmations are taken as possibilities. So they are actually not really in space-time. The idea is that even though nominally these waves have a forward-directed or backward-directed temporal character, I view them as possibilities so that they are not really actual space-time processes. They are possibilities that can give rise to different space-time events, because in general we have these competing absorbers, right? And they're all sending these advanced confirmations, but they can't all receive this one photon. So clearly they're all kind of in play as possible recipients, but only one of them will actually win the photon. And so at that point, according to my approach, my interpretation of this model, that is the point at which you're actually generating a new space-time interval, so that you're creating a set of pair of space-time events that literally did not exist before, so that it's not that you have a signal going back in time or in space and time, but you have the establishment of a new space-time relationship where, from the standpoint of that absorbing atom, there's an absorption event that is kind of like the now. If that atom were conscious, it could say, okay, now I have now received this photon in actuality. So this is a space-time event in my now, but its emission is in my past, because the emission event will be established toward the past of that absorption, because something has to be emitted before it can be absorbed. So it's hard to kind of picture, but if you think of it as kind of a knitting process, that's why I use this knitting metaphor. The offers and confirmations are kind of like going on behind the scenes where you're knitting something. And it's only at the point where you've knitted and you have that stitch and it's on the needle, that's like the absorption. And then the previous row is that where it was emitted from. And that is a new space-time event. So we're not literally sending influences or signals back in space-time. We're actually creating new elements of space and time.
Well, you talk about how there's different levels of reality, and there's like this middle ground that's not as real as an actual event. So how does that work? That there's different... This gets back to your interest since you were a girl, and what is reality?
Right. Well, the way what I take from this is that quantum theory is pointing us to aspects of reality that are veiled or more subtle, and these are the possibilities. So I take it that the lesson that I think we should learn from quantum theory is that it's instructing us that reality has a greater content than we thought. In other words, there's more going on than just space-time. In my books, I use this metaphor of the tip of the iceberg. So space and time that we usually think of as, we usually think, oh, everything that's real is in space and time. And if you say space-time, that's just another way of saying what's real. But what I'm saying is no, space-time is only the tip of the iceberg. It's, if you will, the world of appearance, the manifest world, and that there's this vast submerged aspect to reality that even though we can't detect it with our five senses, nevertheless, quantum theory is suggesting that it exists, and it is these possibilities that are more fluid. And again, you have too many possible events. They can't all happen. You can't have one photon going, what would amount to different momentum directions. That one photon has to pick one momentum direction out of many that it could take. So you have all these possible events corresponding to the different directions of momentum, but only one can be actualized. So there are far more possibilities than the actuality that we experience.
Does this in any way relate to the fact that we only understand 5% of matter and all the rest is dark energy and dark matter, which we don't really know what it is?
Well, actually, in the transactional approach, there's a way to understand these phenomena that people are attributing to what they call dark energy and dark matter, and that it isn't really a different kind of matter. It's a property of the emergence of space-time. So that I'm actually working on this, and I have a paper with Stu Kaufman that deals with a way of understanding the phenomena that are traditionally attributed to dark energy and dark matter through this creation of space-time itself. So that if you look at the way space-time is generated from this process, it has properties that will actually mathematically give you the kinds of effects that we attribute to this missing matter. So it's not really that there's invisible matter out there, it's that space-time has a kind of structure that will lead to these phenomena that we're seeing. But it's a hard sell because, again, most people think, reality is in space-time. Space-time is this container that everything exists in, and that's the kind of usual metaphysical picture. So when you say, no, space-time is a structure that's emergent from something more fundamental, people are kind of, there's a lot of dubiousness about it. But then there are some physicists who are exploring that. So I'm seeing it talked about a little bit more now.
If we go back to our dog, so we have a dog who is not in heat, but she could be. And somehow the male dogs start being aware of this even before she goes into heat. But what makes her go over the edge and go into heat or be willing to release a photon?
Well, interestingly, at the level of the theory, at the level of the math, all you're going to get are probabilities. So the best you're going to do with quantum theory is you're going to get very specific probabilities that this can happen for any particular time that you might measure on your laboratory clock. So, and actually these are there in traditional physics, they're called decay rates or emission rates, and they're already part of standard physics. In my model, those are the probabilities that this process will happen. And it is, in my model, it's intrinsically indeterministic, which means that there's nothing in our current physical theory that you could point to that would say, here's why this happens at this time, or here will make it happen. So we can't point to any cause, but that I find interesting, because I've argued in some articles and in my latest book that that's actually could be an opening for free will. In other words, if things are not completely deterministic and there is this fundamental indeterminacy, that's an opening for some kind of volition to come into play. And that's, of course, as someone who's focused on foundations of physics, I don't have any particular theory of free will. Basically what I've done is try to debunk the usual claims that science tells us we don't have free will, which are wrong, false claims, and I debunk those. But this is one of the things I point to where, look, I think physical laws are truly indeterministic, so that in principle there's an opening for free will. But I don't purport to have any specific model of how that would work.
What would Einstein say about this theory? How does it tie in with relativity, general and specific?
Well, Einstein had a lot of different things he would say. The first thing, he famously said that God doesn't play dice with the universe. So he notoriously did not like this so-called randomness. But if you think of something as being completely deterministic, then on the other hand, it's very hard to say why anyone would have free will. As far as its harmony with relativity, I think that if you look at the way you can get, and this is another area where you could actually get a form of quantum gravity out of this approach, where you think of space-time as emergent from the quantum level, you find that the way that the events emerge are relativistically covariant, and they uphold the relativistic, the strictures of relativity theory. So in that sense, I think he would like it. Although, in the sense that the generation of the space-time manifold out of the quantum level does turn out to be covariant. But again, in his time, people thought of space and time as the whole of reality. So I can't say Einstein would have signed on because it challenges that basic metaphysical view.
So it is that kind of substrate below space-time. Could you call it consciousness?
Well, one approach would be to say this gets to fundamental metaphysics. So is the world made out of some mental substance? Is it made out of a material or physical substance? Is it somehow dual? And I personally, I don't think that dualism makes any sense, because if you've got these two different substances, there's really no way for them to interact. That was, a famous problem for Descartes. Then if you want to be physicalist and just say the basic fundamental substance is just dumb matter, then you really have trouble explaining where consciousness comes from or why anything should be conscious. That's the hard problem of consciousness. So, my sense is that, and I'm not dogmatic about it. And I'm not like a lot of people who are into quantum theory want to say, quantum theory shows that consciousness is this, that, and the other. And I don't like to make claims like that. But I do think that the simplest metaphysics is that probably in some form mind or mental substance is fundamental, because out of that you can get everything. You've got consciousness at the very beginning. You've got phenomena, and what appears to us to be dumb matter. Well, there's no reason, we don't have any reason to assume that it is dumb matter. That's an assumption. There's no empirical warrant for proposing that because I'm knocking on my desk here, therefore it's made out of dumb matter. So the point is that it's a consistent metaphysical view to have sort of a monist metaphysics and say that things are fundamentally mind. Although that's not something I would go around on a soapbox campaigning for, but to me it makes sense.
Mm. It's really tempting, but I know it's fraught to say, okay, entangled particles, once they're entangled, can influence each other from a distance, from in non-locality. So there's some kind of information field, and that could explain why we can do telepathy and clairvoyance and healing from a distance and precognition and retrocausality and all that. But I think physicists don't think that's a fair assumption. You can't really conclude that.
Well, I know that most physicists tend to be empiricists. They would be loath to make those kinds of inferences. At the quantum level, with the non-locality and so on. I explain that in terms of the idea that, again, these things are not in space-time. They are a kind of beneath the surface of the manifest, and so there is no distance. There's actually no distance between possibilities. They aren't separate. They're in some, you can call it some domain if you want, however you want to think of this, but because there literally is no distance, because there's no space-time, it's not a problem for these possibilities to kind of be exchanging information, because they're all at the same place, if you will. They have not separated. They have not really separated until this transaction happens, and that's where the separation occurs. That's what creates a space-time interval, which is a kind of a separation. So that the nice thing about taking these possibilities seriously is that it makes perfect sense of so-called non-locality, because there is no real action at a distance, because there is no distance. So if to me it's a consistent metaphysical view to propose that if consciousness is fundamental, that seemingly non-local exchanges of information of the kind that go on between entangled quanta and so on could go on between living beings as well. There's no inconsistency there. It's not something that I would not go out and say, quantum theory proves you can have telepathy. I would not make claims like that. But there's certainly nothing inconsistent about it. So I think when people are dogmatically opposed to it, to those kinds of, or exploring those possibilities. They're being dogmatic, and they're being empiricist, which is a metaphysical methodological choice to be empiricist, and basically saying that nothing is real, or I can have no knowledge of something unless it affects my five senses. That's a choice. And there's not, science does not require that one make that choice. So it's a consistent view, I think. And I think people who reject it are just kind of being, they're making their own metaphysical choice.
Got it. Quantum physicists talk about an information field. What are the implications of that? And does everyone agree that there's an information field, or is that just some people use that term?
I think that a lot of physicists and philosophers of physics are thinking of quantum states and sort of the quantum world as a kind of an information field. Although usually when people use the word information, it can mean different things. I mean, a lot of people will use information or talk about, say, quantum theory is about information. Many times when they put it in those terms, they're actually being kind of anti-realist, and they're being more like, there's information about what we might know or what we might experience, but they don't literally mean there's a real field out there. So it depends. People can use it in different ways. And often I have a chapter in my Understanding Our Unseen Reality book that kind of criticizes some of the interpretations that rely a lot on this term information, because they're very equivocal about what they mean by information. And you could mean, I could say, these possibilities are like, you could think of them as a real information field that exists. But a lot of physicists will just say, it's just about information, and that kind of, where it's information about what I might find out or what I might experience with my five senses. It's not real. It's just information. So it can be used as kind of an anti-realist approach as well.
But information is something. It's not nothing. So it has some kind of form.
I think that sometimes when people use the word information, they mean gaining of knowledge. So when I gain knowledge, for instance, if you were to tell me something I didn't know about an event that took place, the thing or the reality would be the event that took place. Your passing it on to me would increase my knowledge. So that's the sense in which I mean that they're being anti-realist when they're just thinking of information as something that I can learn about, or something that a way of increasing my knowledge. Then it's only a matter of some person or some observer changing their state of knowledge rather than something that exists somewhere in the world. You know what I mean? It's sort of like the event that occurred. Say there was some accident in New York City, and it happened, and that would be some event in space and time. But not everyone would know about it. So the information would be. It's only information to me if I then change my state of knowledge. So it's kind of an epistemic change in an observer. And I think that sometimes they think of it that way, as just something, may or may not happen, and you may or may not find out about it. But that's all they mean by information. They don't mean that it's actually a field that exists somewhere in the world. Or it's just a possibility of my gaining information that I didn't have before and nothing more.
But it's still something, It's that thought transfer, information transfer doesn't happen in a void.
Okay, yes. So you could have, say, a signal being sent. So you're thinking of a signal being sent that contains that information. So yeah, the information would need to be communicated using something, right? But and I think that's true, and I certainly agree with that. Although many times, when I see people physicists using the word information, they really are meaning more just that it's just a question of whether someone's going to know about something or not. And for instance, that some people will think of the quantum state as not referring to something in the world, but simply being an indication of what I know and what I don't know. And that's the kind of sort of anti-realist use of a quantum state as information that I'm kind of criticizing, where they'll have a picture where, for instance, they'll think of all of space-time as being out there already, and all of the results of measurements are all out there in like a block world from beginning of time to the end of time. And so it's already decided in the universe, if you will. It's already decided where each photon is going to go and what the measurement results are going to be. This is what a lot of people think right now. Mm-hmm. And when I assign a quantum state to something, the quantum state doesn't say which outcome is going to be realized. So it's like an incomplete descriptor. It's basically saying, well, I'm going to apply this quantum state to this atom, even though I know it's according to my assumption, which I don't agree with, but according to this picture, at some future time, that atom will have given off a particular photon in a particular direction, but I don't know yet. So I'm going to give it this quantum state, and that quantum state is simply a measure of what I don't know about the atom, my level of information about the atom, which is partial. And some people will think of that as the information content of the quantum state, which means it's just a measure of what I happen to not know at this particular time. So that's a very kind of, impoverished use of the term information, and that's the kind that I think is that's more instrumentalist. That's like the wave function or the quantum state is just an instrument that I use to label what I happen to know about a system at this particular time, even though according to my theoretical assumptions, some later time it's going to have a definite result, but I don't know yet. So what I'm assigning to it is just a measure of what I don't know. So it's a measure of how much information I have, which is partial. And in that sense, it's just it's a measure of partial information or a measure of ignorance. So it's very observer dependent for a particular observer, because some other observer in the future, if you think there are observers in the future, will have more information, and then they will assign a different quantum state that's more focused to a particular property. So in that view, people are just using quantum states as labels for what they happen to know at a particular time.
So yeah. Okay, like in the double slit experiment, if it's not observed, the pattern will be different than if someone is observing the photons going through the slits. So is that because in this theory that it's determined already that it'll go through the single slit or the double slit, or what determines how observing them changes the outcome?
Well, I mean, in the transactional picture that you explained it in terms of absorbers and conformations, and you don't, there's no matter of fact in the future already about what's going to happen. But the people that I was referring to, the people who think that there's a block world and who have this so-called epistemic view of the quantum state as just a measure of my ignorance at the time, according to this view, there are specific events already in the future where a particular kind of measurement or absorption or detection will be performed in that experiment, and there will be some outcome, and that person just doesn't know it yet. That's what their model is.
It is deterministic.
They actually would. It's not deterministic in the sense that the law doesn't specify, the quantum law does not specify which will happen, and I really think this is a terrible interpretation, so I don't want your readers to think that, your viewers to think I'm espousing it, but as I understand it, they think there are discontinuities. So they will say there's a discontinuity because the law, the deterministic evolution, does not tell you where the photon's going to end up. So there's this brute force discontinuity, but something happens. One of the outcomes just happens according to the probabilities that quantum theory lays out, and that's in the world already, but we just don't know it, because they think of observers as kind of moving through this block world on our little time, what's it called? It's called a world tube, and they have to assume that we're just moving through this block like this. So that's the other assumption that they have to make. But this is a fairly common picture that where people kind of don't have any other way to account for how quantum theory works or what it might be saying about reality. And the only sort of consistent ontology they can think of, because they think space-time is the last story on what's, the full account of what's real, and if something is real, it must be in space-time. So what they do is they just map out this big block, and they assume that all measurements take place to the end of time, and they have results, even though the law does not determine which result occurs. So just as some brute force fact, something just happens, and they conform to the probability. So it's kind of ad hoc in that way. It's just they sort of have to help themselves to the idea that measurements just happen, and they're just in the world already, and everything is there already.
Well, how would you explain that observation changes the way photons go through those slits?
Well, in the transactional picture, observation is not some thing that we have to think about an observer and a consciousness. It's responses of absorbers. So, and you may ultimately say, well, absorbers may be made out of something that's conscious, and that's an interesting thing to explore. But what happens in a measurement is just that you get absorber response. So again, that is indeterministic, but it's not in the picture I propose. It's not that space-time already exists out to the end of time, but when you have these absorber responses, you have a real kind of a collapse situation that I view as a kind of spontaneous symmetry breaking. So you have many possibilities sort of competing, and they can't all happen. And so you have a kind of a spontaneous symmetry breaking that is the actualization of one of those possibilities. So that's all measurement is in TI. It's this interplay between emitters and absorbers.
But I don't understand how observing it or measuring it changes the outcome.
Measuring, well, without absorber response, you won't get any outcome. In other words, so if we think of our excited atom, there's no measurement, there's nothing happening, there's just an excited atom, and then there are some potentially absorbing atoms. And then again, according to this sort of behind-the-scenes sensing, at some point, and again, it's indeterministic, but at some point they can kind of mutually decide, okay, we're going to transact. That means a measurement's going to happen. A measurement is now going to happen. They've all decided. We're going to send out an offer and a bunch of confirmations. That's kind of the first stage of measurement. But there's a second stage at which one of us has got to win and the rest of you guys are going to lose. So that's kind of the symmetry breaking stage. They both happen together. It's just, and again, you can think of that as kind of a brute fact about nature. But in that case, your quantum state is really referring to something in the world that's really going on, and it's not the case that your quantum states are just measures of what I happen to know at some particular time. They actually describe a reality. So that's all measurement is. It's just this process of mutual consent to exchange that photon. But then because you always have more possibilities than can be manifest, one of them has to win. We can think of that as sort of an opening for volition. Perhaps on some level, nature can have volition, and more complex constructions and systems could have a highly developed sense of volition that apply to those as entities, if you will. But it's kind of a manifestation process.
Mm-hmm.
So it's not that observing changes the outcome. It's that it's a process of measurement that is happening on this level of mutuality, where once a measurement situation is set up, only one thing can happen, and so it's undetermined, and they've conformed to these probabilities.
So it's possible that the human observer or measurer could influence what atom accepts this excited proton.
It's possible. Now, I mean, there's nothing in the theory that provides any mechanism for that, but it's possible. There's nothing that excludes it. I mean, if ultimately there's this field of possibilities that where there's no causal, the physics will not tell you what causes one of the possibilities to be actualized as opposed to others. So this is where science is mute. Physics is mute on this. But because there's no theory of it, there's no physical theory, all we have is this kind of spontaneous symmetry breaking where we can't point. This is where you get to the principle of sufficient reason. So you can get into these ideas of will something happen? Can anything happen if there's no reason for it? So it's a tricky question. You know, there's it's also known as Curies Principle because Pierre Curie talked about this, and he was of the view that absent a particular precipitating cause, there's no reason, nothing would happen. So we don't know. We don't know whether nature obeys that or not. I mean, is it something that kind of, as humans, makes sense to us? Like, well, I don't see how something could happen if you can't point to any reason for that one thing happening out of other possibilities. Well, we can't. Science will not tell you. The physics will not tell you. Maybe there is something, you know, and it's fine for people to you know, to pursue that as a possibility. Science can't tell you that it's wrong because there's, I mean, science could just, you know, a scientist could say, well, there's no scientific theory that will justify your speculation. And they could say that. But again, there's no scientific theory that contradicts it either. So it's mute, you know. We don't know. We really don't know why one outcome happens as opposed to the others.
But there have been lots of studies of precognition and retrocausality and all the psi phenomena. So if you were pressed, what would you say explains why? Oh, and like, you know, the random number generators that respond to universal human focus. What is the mechanism for that?
Well, here, you know, this probably isn't going to be a popular comment for your viewers, or you know, but I'm still, I think the jury's still out on actually whether the results that people have reported from these kinds of experiments are genuine positives or maybe false positives. So while I don't exclude the possibility that people can do this, and I don't question people who have experiences, but I mean, there are lots of anecdotal experiences, and I, you know, that's always valid. I'm not going to say, oh, you're delusional because you thought, you know, you sensed your mother's illness, or, you know, this may well be true. And since I believe in possibilities, I believe in genuine creativity, I think it's very possible. But on the other hand, I do have to caution about experiments that have been presented as having conclusively shown these things, because there are some troubling findings. There's a recent article, I've forgotten, I don't have the reference in front of me now, but there are people who did a published study, where they actually found that it's very easy to come up with false positives in psychology, sociology research, and that the field had not been aware of how easy it is to generate false positives, meaning that people think that they found an effect, but that because of other variables and other things that they didn't really know they needed to control for, it may not be a real positive. So I have to I can't endorse these results at the current stage. I'm not sure they're all really, you know, that they're incontrovertible. But having said that, I do think that you can't rule it out. So that there's nothing in the science that can say, no, you can't have these experiences, or no, these paranormal experiences aren't true. They may well be. It's just that I urge caution on, you know, how far to take those results.
Well, I think what's striking is how improbable the results are. You know, it's like thousands, millions against chance that you would have that kind of response from the random number generators at New Year's and at, you know, Princess Di's death. So what else could explain the big anomalies and the odds against chance?
Actually, I am not personally aware of findings that had that kind of large significance, rating. So I couldn't really comment because I mean I know that I've read about the Daryl Bem experience, which he basically kind of disavowed in the end, and I know I've heard of some other experiments, but they've always been like 3%, So I personally don't know of strongly significant findings. So
No, you're right. The findings are usually, instead of 25%, it's 27 or 33%. But even those numbers are improbable because chance would be 25.
This gets back to the way these experiments are often done, where it turns out you can get that kind of apparent effect, but it's a false positive, meaning that the kind of methodology that went on, it's not reliably controlled enough, that it's not a controlled enough experiment, that level of error bar and so on, that level of significance may not be a real positive effect. So this is why I have to be cautious at this point, because there was kind of a big upheaval in the field where people were, and I can send you the link later, or I can show you, the article that I read, where it was actually a bit surprising, because I was at a conference in 2011 where Daryl Bem presented his results, and he presented them as he was very firm that he had been doing things in a rigorous way and so on. And I mean, I have the highest regard for him, and I'm sure his heart is in the right place, and he's trying to investigate these things. But later it turned out that the entire field was following certain procedures that turned out to lead to a lot of false positives. So he wasn't aware at the time that what was considered standard experimental procedure was actually turning out to lead to false positive reports across the field, not just these kinds of experiments, but across the field. And there was a kind of a paper that came out showing that, you can show that people get younger by listening to a Beatles song, by just having certain variables that they didn't control for carefully. They get an absurd result. And so you can get these false positives. And later, Bem kind of made these comments that he sort of disavowed his earlier experiments. So I've had to kind of reassess and go, I don't know whether these are real positives or false positives at this point. So that's why I can't say, well, you're getting this because so-and-so, because I don't know we're getting a real effect.
Right. I think Dean Radin has done a lot in collecting meta-analyses of psi study after psi study after psi study in his books. So I think he collects a lot. But let's talk about your books. So let's just maybe summarize the transactional interpretation of quantum mechanics, the reality of possibility. It was published in 2015 and 2017. What was your main point in that book?
Well, that was to try to get people to consider this idea of the possibilities. In other words, that there's more to reality than space-time, and that's just the tip of the iceberg, and that quantum theory is referring to this field of possibilities, that kind of introducing people to the idea that you need to think outside the box, that space-time is a box, and you need to think outside that, and also to try to convey the basic transactional process in these symbols that were easier to kind of see what's going on. Mm-hmm. So that was the goal there, because it's hard to picture. I mean, people have trouble with this idea of these advanced confirmations and so on. So I think and it's easier if you can kind of look at an illustration.
So how would you define consciousness? The word I see most is awareness, but I don't know. Is an amoeba conscious? Where do you go with consciousness as a definition?
Well, I'm not a philosopher of mind, so I don't claim any great, scholastic, expertise in that. But I think of it as having two aspects, I guess. You could say that the basic feature of consciousness is just awareness, but the ability to be aware. So the fact that, we each have our own subjective sense of being aware of something is a kind of a basic experience that in some sense is sub-empirical. It's not anything anyone can illustrate scientifically, so that you can never prove you're conscious, right? But it's an internal experience of awareness. And then the other aspect of it would be awareness of something, so that you have sort of a field of awareness, which is like the intransitive aspect of it. But then there's more the transitive form of it, which is being aware of something. So I kind of think of it as having those two aspects. As to, whether an amoeba is conscious, I think that it's an interesting, if you think of the basic substance of the world as being consciousness, then of course you have to kind of wonder, well, what is it like? Is a photon conscious? What is that like? I don't know. But you can ask those questions, and perhaps the different features of reality have different forms of consciousness and awareness.
What's your personal feeling about what happens after you die? Do you think your consciousness goes on?
Yeah, I just sure don't know. I have to say, I've been reading some really interesting literature I've read some channeled literature by Paul Selig, by other people. I've read an entire book ostensibly written by Lord Maitreya, who as channeled through, I think it's Kim Michaels. So it's fun to read these things, and they're fascinating. If this information is true, then I suppose we're all life streams, and we go on to something else when we die, and the body is a shell that we just let, like a snake sheds its skin, and we go on. I'd like to think that, so I don't really know. It's a nice thought.
After my grandmother died, when I was in high school, she would come and open kitchen cupboard doors and pop corks out of wine bottles. And my mother would say, "Gammy's here." We'd say, "Hi, Gammy."
Could be. I know that would be very cool. I guess one thing, I've never personally had a paranormal experience like that. I've never. I would really like to. I have not had that happen to me personally. I guess, yeah. I don't know. I guess maybe I've had interesting dreams and that sort of thing. But it would be interesting to have a real paranormal experience someday. But
what you could do is Windbridge has a list of mediums that they've qualified as being outstanding mediums. So you could have a vicarious experience through a medium.
Maybe I'll try that.
It'd be fun. Yeah. I've been thinking about it. I did. One of the people that I interviewed, her mother was a medium, so I did a session with her, but it was nothing. It was just like she was BSing. And my brother had died, and there was nothing she said that was in any way in contact with who my brother was. Mm-hmm. So you have to get someone who's from Windbridge, who's experienced.
Yeah, actually, when our cat got lost for a month, when my daughter moved out to Portland, we got him back, but it was a scary month. I actually talked to a couple people who purported to be animal media, people who were sensitive to animals, and I don't know if I really got any useful information from them. I think the one who I actually paid gave me information that I think later turned out to be completely bogus. So yeah, you never know. You never know.
Right. Understanding Our Unseen Reality, Solving Quantum Riddles, that in 2015. Where were you going with that one?
Oh, let's see. Did you already ask me about that one, or maybe I misheard?
Well, we talked about transactional interpretation of quantum mechanics, the reality of possibility.
Oh, yeah, I think I misheard you, and I thought that you were talking about the later one. The first one was more for the academic audience. That the first one, I'm sorry, that you asked me about was more to lay out kind of for the academic audience the basics of this possibilist picture. The unseen reality one in 2015 was more for the layperson, so that was. But the difference was it was kind of the same basic goal, but oriented more towards the person without the background, without that background, so that I use these illustrations to kind of convey the idea.
Your newest one, Adventures in Quantumland, Exploring Our Unseen Reality. Where did you go with that book?
That one was further developing some of the subtleties involved with kind of the metaphysics of the picture, because people are still, I think it's a challenge to understand, well, what is she talking about? What do you mean space-time is, what do you mean we create space-time out of these transactions? So I was trying to get into more detail with that. And into a little more in-depth discussion of the implications of the metaphysical picture of possibility, and to kind of talk more about the challenge of letting go of some of these kinds of, the ancient Greeks were brilliant and they were great, and they had a lot of really great, important ideas that led to progress, but they also had some ideas that I think have constrained us, this sort of static, eternalist idea that the whole world is out there already, or that the whole, space-time construct is out there. There was kind of a physicalist idea, the atoms in the void. And what I wanted to do was counter that a little bit and say, not all the Greeks actually thought that way, that there was a more of a becoming, a more dynamical aspect to their thought too, and to kind of talk about those ideas in help people to get a little bit of perspective on why we make certain metaphysical assumptions about the way the universe has to be when it doesn't have to be that way. And I also talked a little bit more about free will, because I became more aware of some of the very negative statements coming out of a lot of the physics community and the science and the neuroscience community, making very dogmatic, categorical denials of free will. And that it's actually very irresponsible, and that there's actual harm. There are real consequences that come from convincing people they have no free will. When you don't know that. You've got certain premises, and they have these premises that, based on my premises, you don't have free will. And I'm like, well, your premises are debatable. So I spent some time on that too.
We certainly live our lives as if we have free will. I mean, we make decisions all the time that change the outcome, and we decide, or we think we decide anyway. Yeah.
Well, we have an experience an experience of having free will. Now, a lot of these people will say, well, it's a delusion.
Oh.
I was talking to someone who at a conference in Germany, and he said, okay, if he agreed with me that we probably do have free will, or at least it's premature to pronounce the death of free will. And he said, if someone tells you don't have free will, just start smacking them across the face.
Yeah, right.
And let them decide, oh, she really has no choice. She really, okay, I think we do. I mean, I think we do. And the basic point is, I could never prove that we have free will, but the burden of proof is on the denier. The burden of proof is on the person saying you don't have free will. Well, they can't prove we don't have free will, and especially based on the premises. When you see the premises that they're working with, they're very narrow and very easily questioned. So,
Hindus and Buddhists might say that our karma, set up by past lives and reincarnation, predisposes us to have certain patterns in this lifetime. But even in the face of karma, we have choices. You could work through your stuff, or not work through your stuff that you're presented with.
Yeah, I mean, I think a lot of people get confused about this, because saying that you have free will doesn't mean you're not influenced. It doesn't mean, oh my goodness, it takes a huge effort of will for me to go out for a run when I'm tired, feeling tired and lazy. Or, it's not to say that we don't have enormous constraints on us. We do. I mean, in this reality, we have enormous pressures. But the fact that we have enormous pressures, or however you want to put it, karma, we are surrounded by forces, many of them beyond our control, does not mean that we don't have some element of choice. So,
Right.
I think there's a lot of confusion about that.
So are those your 3 books, or have I left out any books?
I have a few other books that are, I have a collection, Quantum Structural Studies, that is an edited collection that's just a invited contributions for various physicists and philosophers about the classical or space-time emergence from the quantum level. And then I have, my hobby is Tudor music in Renaissance England, and I wrote a screenplay with my sister about William Byrd, who was the court composer for Queen Elizabeth I. Just because I love his music, I've done singing, in the sacred vocal music. We wrote a screenplay about his life because it was such an amazing life. So,
did it get put into action? This
not
play?
yet. If you've got any producer friends out there, it's a great story. I'm hoping maybe someday. I mean, it's not your Hollywood story. It's basically the plight of the Catholics under, during the Reformation. And I'm not Catholic. I just happen to enjoy that music. And William Byrd was a Catholic who was working for a Protestant queen, and a very interesting life in terms of doing a lot of very shady things and getting away with it because she liked him so much and she liked his music, and he was constantly being subversive and hanging out with Jesuits and traitors, and she kind of looked the other way. So it's fascinating, cloak and dagger stuff. It's really
maybe you could publish the book, the play, as a book form.
It's actually on Amazon. I have the screenplay as a Kindle book, and actually, yeah, you can get a hard copy as well.
Good.
So it's called The Harmony of That Heavenly City, which is a line taken from the autobiography of John Gerard, who was a Jesuit, who was involved in a lot of those subversive activities. Wrote great books. So it was a fun project.
Terrific. So when I ask you what you do for fun, it's obviously play the violin, write. Do you still do art? What's fun for you?
I actually, now I play piano because look at that tiny little pinky. I mean, it's no good for playing violin. I just kind of hurt my hand with the violin, so I play piano now. And I do a little singing for fun. I like to go hiking and do a little jogging. I don't do much art anymore, so it's more music and hiking and that kind of thing.
And you have grandchildren, right?
I'm sorry?
You have grandchildren.
I have one grandson. He will turn 1 year old on July 4th.
Oh.
So
does he live near you?
Right now, his daughter is a lawyer, so she just got a position as a federal court clerk down in Mississippi. She used to live in the Baltimore area. That they're in Greenville, Mississippi. Greenville, Mississippi right now. Lovely place. People are really friendly, and we're looking forward to going down there soon to visit them for his first birthday. So
nice.
That'll be exciting.
Finishing up here, in the face of climate change, growing inequality, the rise of autocrats, are you optimistic or pessimistic about our future as human beings on this planet?
I try to remain optimistic. It's scary. It is scary. It is challenging. We have big challenges. We have to think positive and get out there and tell our political leaders to listen to us, even though they don't want to. Well, we've got to keep working, and I think there's a lot of hope. It is challenging, though. I mean, I think we're at a pivotal moment, and we've got to kind of push through and make a lot of changes. So I think that there's the climate emergency mobilization that I've joined, and I try to call my politicians, and called the European Union folks and said, stop listening to polluters, listen to people. Let's get moving on this, and let's take it seriously.
Right. Thank goodness for the teenagers like Greta Thunberg and the climate change. Those they're making a difference, I really think.
Yeah, good for them. They know it's their future that's on the line. So good for them, yeah.
Anything else that we haven't talked about that you think is significant and we should include?
I guess I would just point out, the science versus religion thing. I mean, I think that needs to be corrected. Science and spirituality, where a lot of people like to think of these as at each other's throats, and really they're very complementary. And I think that scientists need to be a little more open-minded about their metaphysical assumptions, and spirituality. Obviously you can go off on crazy flights of fancy, but you can become dogmatic in science as well. So I think both schools need to listen to each other. And I write about that a little bit in the final chapter, in chapter 7 of my latest book, Adventures, where I try to reconcile. I say we can reconcile the scientific and the spiritual traditions. They're different ways of knowing. Each has its limitations, but each has its power, and they need to work together more closely. So
right. There's a place for logic, and there's a place for intuition and mysticism as sources of information.
Yeah, absolutely. I mean, there are ways of knowing. I think that there are inner ways of knowing that are legitimate, that many scientists would scoff at because they're not empirical. But again, I think if we take quantum theory seriously, it's pointing us to an aspect of reality that is beyond the empirical, that is sub-empirical. It's pointing to it indirectly, but I think that's the natural takeaway, and that we need to take that seriously. And human beings are way beyond it. We're way more than just computers, logical systems. The rational is always limited in that, there's Gödel's theorem that points out that every logical system has its limitations. So science kind of has to accept its limitations and not try to judge other ways of knowing based on standards that don't apply necessarily. But I think the two can complement each other, and that there needs to be a lot more open-mindedness around that interface of science and spirituality.
I'm wondering if this substrata, we'll call it, that's below space-time, do you think that existed before the Big Bang?
It could well. I mean, and in fact, I mean, the sort of natural way to see things is that was the first thing to come into being, that you have to have possibilities before you can have actualities, right? That you can't have an actuality if there's nothing there that makes it possible. So in a sense, that could be viewed as a subtler level of creation or coming into being, however that happened, that first possibilities are generated. And out of the possibilities, then you have the actuality. So that's sort of the natural way to interpret it, I think.
Great. Thank you. This has really been interesting.